Have you ever seen an AI do something that just seems, well, impossible? And I'm not talking about writing a poem or making some weird piece of art. I'm talking about AI learning the fundamental laws of physics just by watching videos. Yeah, you heard that right. Let's get into it. You know, for decades, just trying to simulate the real world in a computer has been one of the hardest things to do. I mean, think about programming the way water splashes or how light bounces off a metal surface. Demis Hassabis, the head of Google DeepMind, talks about this from his days designing video games. He says it's just this incredibly painstaking, difficult process to get right. But here's the crazy part. These new AI video models like Google's Veil, they're starting to do this exact thing. And they're getting shockingly good at it. They can create these videos of, say, clear liquid getting squished in a hydraulic press, and they nail the physics of it. Not because someone programmed the laws of fluid dynamics into them, but because they just learned it from watching tons of videos online.
I mean, that just seems to defy logic, right? How can a system that has zero explicit knowledge of physics equations somehow reverse engineer the rules of reality just by watching stuff? It's a question that, honestly, points to something way, way deeper about the universe itself.
So the secret here, it turns out, lies in something these AI models are uncovering. They're not just memorizing pixels on a screen. No, they're actually extracting an underlying structure, a kind of hidden pattern in how all this stuff, materials, light, actually behaves. It's like they're finding a shortcut that nature itself uses.
And let's be super clear, these are not simple problems. The things AI is starting to figure out intuitively, like fluid dynamics, are governed by these infamous things called the Navier-Stokes equations. We're talking about problems that require massive supercomputers and days, even weeks of calculations to solve with traditional methods. And yet, AI seems to be finding a more direct route.
To really understand how this is happening, we've got to turn to an idea from one of the most brilliant minds working today. It's an idea so big, so provocative, he actually presented it during his Nobel Prize lecture.
So yeah, we're back to Demis Hassabis. He's not just some AI pioneer, he's now a Nobel laureate for his work on solving one of the biggest challenges in biology. And his experience cracking that code is what led him to this powerful idea about the nature of reality itself.
Okay, just take a second to absorb that. The sheer audacity of this statement is what gets me. What he's suggesting is that any natural pattern, from the way a protein folds itself up to the way a galaxy forms, has a kind of structure that a regular old classical AI, like a neural network, can efficiently learn.
So what does that actually mean for us? Well, in a nutshell, it suggests that nature has a kind of hidden cheat code built into it. And AI is getting exceptionally good at finding that code.
Hassabis calls this cheat code learnable structure. See, unlike a purely random abstract problem, natural systems have been shaped over eons by processes like evolution or just plain physics. And these processes, they leave behind a pattern, like a gradient or a roadmap. It's not obvious to us, but for a learning algorithm, it's a massive shortcut.
And this comparison here makes it crystal clear. Take protein folding. It's not like an abstract math problem, like factoring enormous numbers. Factoring might just be totally random, with no real pattern to learn. You might even need a quantum computer for that. But protein folding, because it's a natural process, it has this underlying physical structure that an AI like AlphaFold can actually learn to follow. It makes a seemingly impossible problem totally solvable.
And look, this isn't just some cool theory. This is exactly how DeepMind pulled off its most famous breakthroughs. They've already proven this whole idea works in the real world.
The protein folding problem was the perfect test. For 50 years, scientists were completely stumped. How do you predict a protein's complex 3D shape just from its basic sequence of amino acids?
I mean, the scale of this problem is it's mind-melting. A single protein has more possible ways it could fold than there are atoms in the entire known universe. Trying to check every single one is literally impossible.
So, how did AlphaFold do it? It didn't try every single possibility, that's for sure. Instead, it learned a model of all the physical forces at play. And then, this is the key, it found that learnable structure, that gradient that nature itself uses to fold proteins in milliseconds. By just following that gradient, it could navigate this impossibly huge search space and find the right answer super efficiently.
And the proof just keeps piling up, from AlphaGo mastering the game of Go, another problem with a ridiculously vast number of possibilities, to newer systems like AlphaFold 3 that can model the intricate dance between DNA and proteins, to WeatherNext predicting chaotic weather patterns better than our best supercomputers. They are all finding nature's cheat codes.
Okay, so this brings us to a much bigger, much more mind-bending question. If all of nature's systems have this learnable structure built into them, What does that mean for reality itself?
Hassabis thinks this could actually reframe one of the greatest unsolved mysteries in all of mathematics, the P versus NP problem. Basically, P versus NP asks, if you can check an answer to a problem easily, does that mean finding the answer has to be easy too? For decades, we've thought of this as this purely abstract mathematical idea. But his conjecture raises a totally wild possibility. What if the answer isn't about math, but about physics and the very structure of our universe?
This whole thing is rooted in a much deeper idea, that information might be the most fundamental thing in the universe, even more fundamental than matter and energy. And if you start to see the universe as this giant information processing system, then its rules just become a question of computation.
And that leads us to the ultimate takeaway here. If Hassabis is right, if reality itself is built on these learnable patterns, then it means a powerful classical AI running on the kinds of computers we have today could, in theory, uncover the most fundamental rules of the universe. We might not need some crazy quantum leap, just a smarter way of learning.
So it leaves us with this really fascinating final thought. We're building tools that are learning to see the hidden structures that shake literally everything around us, from a splash of water to the folding of a protein. The question isn't if we can find nature's cheat codes anymore, it's what other secrets of reality are just out there, waiting for us to find them.